Assalamualaikum. My group will be presenting about electrical power transmission. Group members: Aino, Dania, Nadia, Razin, and Izati. Introduction. Electric power transmission is the process by which large amounts of electricity produced at power plants such as industrial-scale solar facilities is transported over long distances to consumers for utilization. The network that transmits and delivers power from the producers to the consumers is called as the transmission system. This energy can be transmitted in either AC or DC form. Traditionally, AC has been used for years now, but HVDC, which is high voltage DC, is rapidly gaining popularity. Due to the large amount of power involved and the properties of electricity, transmission normally takes place at high voltage, which is at 69 kV or above. Electricity is usually shipped to a substation near a populated area. At the substation, the high voltage electricity is then converted to low voltages suitable for consumer use, and then it is shipped to end users through a relatively low voltage electric distribution lines.
So these are the classification of electric power distribution network, which is the first is generation, second is transmission, the third is distribution, 4 transformer, and the last one is the residential consumers. Next, we continue with the slide, which is contain types of circuit in electric power distribution. So the first is the power transmission circuits, and the second is power distribution circuits. Third is busbar circuits, and the fourth is feeder circuit. Next, control and protection circuits, and the last one is communication circuits. I will briefly explain about the 6 types of circuit in electric power distribution. So the first one is the power transmission circuit, which is the circuit from the generating station and the generator step-up transformer to distribution substation. So basically, this power transmission circuit is operating at voltage range from 69 kV until 765 kV or maybe higher depending on the particular transmission system. So the second one is the power distribution circuit. So distribution circuit is receive high voltage electricity from the transmission circuit before and lowering this voltage suitable for consumer use. Next, the power distribution circuit typically operating at voltage range from 4 kV to 35 kV, which is lower than power transmission circuit. So the next is the busbar circuit. Basically, the busbar circuit is the conductor which used to connect various components in a substation. So such as transformers, circuit breakers or others. So the busbar circuit offers a hub for power distribution and permits flexibility in how the electrical network is set up. The next one is feeder circuit, which from distribution circuit split off into feeder circuit. So this feeder circuit is distribute electricity to a particular areas. So basically, feeder circuit operating at lower voltage such as 120 volt or 240 volt for residential or small commercial application. So the next one is control and protection circuits. So the circuit is for manage the substations, machinery to guarantee its dependable and secure operation. So protection circuit isolate the defective area by activating protection device such as relays or circuit breakers when they detect faults like overload or short circuit failures. So the last one is communication circuit, which is the circuit transfer the electric power from control and protection circuit to our house. So Communication circuit is facilitate the exchange of information between electrical substation, control centers, or remote monitoring system. So communication circuit is allowed for real-time grid synchronization, control and monitoring. So this is important for us to keep in mind that this type of circuit can variety based on the layout, configuration and substation voltage level, as well as the features of the local electrical grid.
Moving on to the next one, I, the Minister Binti Mama Aris, will explain to all of you about transformer used in the power transmission. As we know, the transformer is used to convert the alternating current voltage, or known as AC voltage, from higher volt to the lower volt, or vice versa. In electrical power transmission, there are two types of transformer that are used. The first one is step-up transformer and the second one is step-down transformer, or specifically called distribution transformer. Step-up transformer is a transformer which the primary voltage is lower than the secondary voltage. The step-up transformer is needed to convert lower voltage to the higher voltage. Why do we need higher voltage here? Actually, we need more voltage to go through the transmission line. This is important to increase the efficiency as the electricity is transmitted over long distances. There are inherent energy losses along the way. Hence, the high voltage transmission minimizes the amount of power lost as electricity flows from one location to the next one. Moving on, we have distribution transformer as one part of the step-down transformer. Unlike step-up transformer, this transformer is a transformer which the primary voltage is higher than the secondary voltage. This type of transformer is needed to convert the high voltage to the lower voltage. Why do we need to lower the voltage after going through the transmission line? This is because high transmission voltage that is used for the long distance transmission is not suitable or safe for direct use by consumers. Hence, we need to lower down the voltage to the suitable voltage required by the factories, offices, or houses. Step-down transformer is also able to help regulating and maintaining a stable voltage level throughout the distribution system.
Exponent of wire and cables. Wire are one of the important components of the conduction of electric currents. Most wire and cables are products with cross-sectional shapes and long strips, which are due to the characteristic used to form lines or coils in system or equipment. Therefore, in order to study and analyze the structural of composition of the cable product, it is only necessary to observe and analyze from its cross-section. The structural element of wire and cable product can generally be divided into four main structural components, which are conductor, insulating layer, shield, and soulmate, as well as fitting element and tensile element. According to the requirement for the use and application of the product, some products have a very simple structure. Name and material of the structure of the product. The first one is wire. Wire is the main component of the most basic essential product for performing the function of current or electromagnetic wave information transmission. Wire is an abbreviation of conductive wire core. It is made of non-ferrous metal with excellent electrical conductivity such as copper, aluminium, copper-clad steel, copper-dressed aluminium, and fiber optic. There are several types of wire, namely bare copper, colored wire, single branch wire, standard wire, and colored wire. Second is insulation layer. It is a component that wraps around the edge of the wire and plays the role of electrical insulation. It can ensure that the current electromagnetic wave and the transmitted light wave move only along the wire and do not flow outward. and the potential of the conductor can be isolated. That is, it is necessary to ensure the normal transmission of the wire functionally, but also to ensure the safety of external objects and people. The conductor and isolation layer are two basic components that must be held to form a cable product. There are several main materials which are PVC, PE, XLPE, polypropylene, fluoroplastic, rubber, paper and mica tape. The third one is filling structure. Many wire and cable products are multi-core. After this isolated core or pair is cabled, one shape is not round and the other is a gap between the isolated core. There are large gaps, so the filling structure must be added during the cable. The filling structure is to make the outer diameter of the cable quite round, to make it easier to wrap and extruding the seat. Material for this filling structure is PP rope. The next one is protecting. It is a component that isolates the electromagnetic field in the cable product from the external electromagnetic field. Some cable products also need to be separated from each other between different wire pairs in them. It can be said that the protective layer is a kind of electromagnetic isolation screen. Conductors that protect high voltage cable are to homogenize the distribution of electric field. There are several types of material used in this protecting, which are exposed copper wire, copper clad steel wire and colored copper wire. The last one is tensile element. In a word, the tensile element plays a major role in specially developed small and soft products that require various bending and twisting. The main material for this tensile element is steel wire.
Conclusions. Electric power transmission is the movement of electrical energy from a generating site, such as a power plant, to an electrical substation. The interconnected line that facilitate the movement from a transmission network. This is distinct from the local wiring between high voltage substations and consumers, which is typically referred to electric power transmissions. There are 6 types of circuit that is used in electric substation, which is power transmission circuit, power distribution circuit, busbar circuit, feeder circuits, control and protection circuit, and communication circuit. Next, there are 2 types of transformer used in electrical power transmission, such as step-up power transformers and step-down power transformers. Last, material used in the production of wire, which include several aspects, such as type of wire, insulation layer, filling structure, and tensile. That's all from us. Thank you for listening.